Hey, what's going on, guys? xiangqi here. In this video we're gonna have a look at the game that I would bet you have never ever seen before, and this game is a Hexpawn. So Hexpawn is another Kim 1 game from 1978, but what is interesting about this that it's a machine learning program. So the idea is that it sort of learns from its own mistakes, and if you want to know a bit more details on how exactly this kind of works, I have an exclusive interview with Bob Leedom, who is the author of this legendary program, and it's available on my xiangqi's channel. So we have a 1 hour interview with Bob where he's talking about the retro software that he created back in the day for Kim 1, which is my favorite computer, to be honest. It's based on 6502 processor, which was just right there on the scene back in 1976, and this was kind of 2 years later. So yeah, a very interesting insights from the author, basically. So the challenge was actually to create a chess-like game that would be displayed on the 6-7 segment LEDs display. So sorry, this is how the output of the Kim 1 kind of looks like. Well, this is an emulator. It doesn't exactly represent how it goes on the real Kim, but anyway, so in the real Kim there is no space here, which makes it a bit more kind of tight. But anyway, we have 4 digits on the left that represent the address we're currently at, and the 2 digits on the right representing the data that is available in the current address. So we can loop through the addresses, we can set up the data. Let's say if I go to the data mode, we can just set like some value there, like some another value, and if we go back to the address, say 0000, and we can now see that 2 values that we just input are right in there. So in the previous video I've been demonstrating another game that was actually intended to be running on the Kim 1, and that was the world's first commercial chess program, which is called Micro Chess, and it was written by Peter Jennings, but it was running entirely in the serial terminal, so the TTY basically, which didn't involve the display in order to actually show the chess pieces or position or whatever. So what Bob did with this game, he actually was making use of this 7-segment LEDs in order to sort of display chess pawns, and hence the name Hexpawn. So if we have a look at the structure, so we really have 3 ranks here, right? And we have 3 files as well, and 3 pawns on the for white pieces, 3 pawns on for black pieces. And now you might be wondering how the heck to actually display this. So here is the hack. The white pieces, or your man and his man, it's not really white and black, it's just your man and his man, Kim's man, right? So these are just flashing here, solid, these are like solid, and these are flashing. So that's how to distinguish between the, let's say, white and black pawns. And also, if you have a look at the 7-segment LED as well, then you see that here in between you also have this tiny little segment. So the chess piece might be either here or here or here. Like, not the chess piece, like the pawn, basically, that is represented by this tiny little segment of the 7-segment LEDs. And now there even a software, there even an original source code in the format of a paper tape exists for this game. And I believe if one is going to be patient enough, he would be able to actually input all the bytes right into the emulator, for instance, just byte by byte, and that would most likely, if the emulator is accurate enough, that would probably, most likely, would result in playing this game. However, we're not going to be doing this in this video because it kind of takes too long, and it's not really the video about Kim 1, unfortunately, because I really love that computer, but rather about chess. And just to give you an idea how this game kind of feels and how it learns, we're going to be using this Commodore 64 based emulator. So I just refreshed the screen here because here the program already learned something, so I just really want to start this from scratch. So I press start, and let's go full screen apparently. And yeah, one last thing, so I'm not going to be telling you how exactly this kind of algorithm works. So if you're interested to know how this works, you just feel free to watch the video where author actually explains to me how this works, and that's going to be really exciting. So now without further ado, let's actually give it a try, and I want to go to the full screen mode here. Okay, and probably I just want to make the screen like this. Yeah, this should be just fine. All right, so no, I don't need instructions. Well, actually, let's read the read through instructions again. So your pawns are this like solid dot and mine paths. Well, it's the version for Commodore Pad, but literally Commodore bought MOS Kim1 and built its pad with Commodore 64 and other machines on top of that. So literally it's just like the Kim1, but the next step of the Kim1, and it's kind of a bit updated version, but the game still remains the same because they were kind of compatible. Just the display is different, but the game itself is really the same. So use the number pad. So you remember, like we had this number pad. Because, well, I'm not sure. Maybe this help file comes from the original game. It's a bit strange because it couldn't really show this. But well, I'm not sure really. But anyway, so let's keep reading. So give the position you move from, then the position you want to move to. So just like in chess, from square to square, and then you may move straight ahead if the space is empty or diagonal to capture a pawn. So the pawns are moving just like the pawns in chess move, so you can't capture forwards. You just only only capture diagonally. And to win, so this is important. So let me just move the window. Oh, just can't. I don't have a mouse. Sorry. So to win, and move a pawn to other side, or block all of my moves. So well, it's really much easier to actually keep going and see how this works. When we were playing. So just to give you an idea, I want to emphasize how this program kind of learns. So instead of just playing, I would rather be making the same moves, and just in order to demonstrate how the program would be advancing every next iteration. So every next game, I would be playing the same moves. So first it would let me win, and then it won't. And this is going to be happening until there will be no losing moves at all. So it's a bit of a spoiler, but anyway. So we have. So I just want to move the central pawn one step ahead, and I need to say so from 2 to 5. And here we go. So prints the board again, and now he already lost because I can go from 5 to 6, 7, 8 to 9, and I capture and I win. So you see, like, you win, he lost. So 1 win out of 1 games. So now we're going to be doing exactly the same moves to see how the program improves, right? So I'm going from 1, 2 to 5. All right. And now he is going to lose, but already a bit different way, which is interesting. So I just say from 5 going to 6, 7. All right. So I win again. But now interesting thing is going to be happening. So I now say from 2 go into 5, and you see, like, already what it does, it actually kind of captures my piece here. So I would say 3 captures to 5 in this case. Okay, and okay, he moves forwards, and yeah, I believe here he would win already because the next move he's going to win. So 1 goes to 2, 3, 4. Okay, and then he just wins. Okay. So yeah, now he won the game. Okay, so let's try another thing. So 2 goes to 5. So that is, it kind of improves, right? And now let's say 1 takes to 5, right? And he captures, and now 3 captures to 5, and I win. All right, so now let's try one more time. So 2 goes to 5, all right, and again 1 goes to 5. So playing the same moves here. And here you see like you can move, so I win. So he found another solution to actually kind of win. All right, so now let's try another move. So let's say going from 1 to 4, for instance. Okay, so he captures, and I need to say from 2 to 4. So I capture as well, and yeah, so yeah, he wins this one. All right. So yeah, it's not really that great. Let me see if I can do something else here. So probably, yeah, still here. Yeah, he didn't run out of the bad moves yet, so he gives me a chance now. So now say 3 takes to 5. Yeah, now it takes. Okay, now I can just go from 5 to 6, 7, 8, and I win. Okay, let's try again. So 1 goes to 4. Okay, and yeah, now I can simply win by saying 1, 2, 3, 4 goes to 8, and I win again. All right, so now he should be running out of this losing moves, so let's try again. 1 goes to 4. Okay, and yeah, now another trick. So to win, I think if I go 3 goes to 6, he can move, so I win. All right, so 1 goes to 4 again. Okay, he captures, and 2 captures to 2, 3 to 4. Okay, and now he wins again. Now he kind of wins again. Here is my move. You can't move, so I win. And so far and so on. So this was Hexpawn, guys. And I don't know, for me personally, this game is absolutely tremendous. So feel free to watch the interview with Bob Leedom, who is the author of this game. Well, not exactly this version. I mean, like, he didn't write this for, well, as far as I'm aware, as far as we've been talking, he wasn't doing this for Commodore PAD, so probably it's sort of a port. But he was making this for the original King 1. And I didn't ever try that, but I believe playing this on the original King 1 was a real fun. And a part of this game, he also made many other absolutely tremendous games for King 1. And his idea was actually to make a video game that would be running on the 7-segment LED displays, LEDs display. So if you're interested, check out the interview. And this is it from my side, guys. Thanks for watching. Until the next time, and take care.